Testing, testing. Perfect. Streaming.
Okay. Hello, guys.
Hang on 1 second. All right, guys. We are streaming now. Today I've got Stan from Galactic Exchange, who is generously stopped by on an impromptu basis to tell us more about what they're doing at Galactic Exchange. So I'll hand it over to you. Maybe you can give us some background on the company yourself and what you guys are doing.
So our company is a company that is doing something like a blockchain for big data. We're thinking about uniting AI and then data and what we can do about this stuff. So it's actually very interesting. So what I'm actually going to talk to you guys about is not exactly what we are doing now, but what the vision is, say, for the next 10 years. So these are some ideas which I think are not gonna only apply to us, but also to other people. You know, the roadmap, how we can introduce AI in our daily life and what AI can do for us. So as far as my background, I did my PhD in physics, and then I was a researcher at Los Alamos National Lab at Stanford University. I worked at Sun Microsystems Java Virtual Machine team, and then at a number of crypto startups. And then I founded one startup which was sold to a company in the UK, and that's my second startup. So this startup was funded by two venture firms in Silicon Valley, Floodgate Capital and Signia Ventures. So that's pretty much the background. Now let's maybe go to
let's do a screen share. We have some slides here, so we're gonna do a quick screen share so Stan could walk you guys through. So Stan. Why don't you go ahead and you can tell me, and I will move the slide.
Okay. So it's actually quite an exciting time, I think, and also a crazy time. You guys probably heard about all of the craze which is happening this year with the ICOs and the cryptocurrencies. And the question is, you know, is it all hype? Some people say it's all hype and crazy and it's all gonna burst. And some people are saying it's like all gonna go up, and some people predicting a $5 trillion valuation of all of this crypto stuff, but by the year of 2025. So the question is, what's really happening? And I think, you know, I think the truth is somewhere in between. So there are some companies, there are some crypto companies which are really doing some crazy stuff, and people just trying to do some quick money. But there is really something important happening. So, and it's actually...
So you're talking about all the scams that are going on, the 99% of all the ICOs, right?
Right.
Where they could just use fiat instead of issuing their own tokens, correct?
Exactly. Okay. But if you think about the previous, you know, disruptive transition which happened on the internet, in 95 and 99, there were lots of scam companies. But on the other hand, there was Google and Amazon. So there were really people doing computer science. And the question is, you know, where is the computer science and all of this stuff? So the thinking, I'm going to talk to you guys about the thinking that I have about this, and we have. And so when you think about cryptocurrencies, if it's just a cryptocurrency, you know, you have Bitcoin and you have Ethereum, doesn't actually look like you may have many more cryptocurrencies. It almost looks like it's already done, right? You already have this stuff. But you can start thinking about this entire thing not in terms of cryptocurrencies, but in terms of crypto service networks. And I'm going to explain in a second what I mean actually when I talk about these networks.
Should I go to slide 2?
No, let's just wait here for a second. So let's take Uber, right? You have Uber. Uber is pretty much a collection of people. Those are Uber drivers, right? And Uber drivers are in general very happy because they have no managers, right? You can drive Uber today, and tomorrow you can be a Uber customer. You can, you know, drive Uber for an hour, for 2 hours. So you have this network, essentially, which you can easily join, and you can easily leave, and you can make money on this network. And the network judges you in terms of the algorithms, right? If you are an Uber driver and you drive well, people like you, they put lots of stars, so your rating goes up. And then if you're doing some bad things, for instance, you don't come in time or stuff like that, you actually get penalized.
Mm-hmm.
So you have these algorithms which are in a sense managing you. And a good thing about the algorithms that Uber drivers like is that the algorithms are actually always true, and you don't have like a manager if you work like at a Burger King or McDonald's,
Mm-hmm.
where the manager is not really judging you by your job, but maybe discriminating you or may not like you. So all of this human stuff is taken
Mm-hmm.
away. So now if you take Uber, Uber still has a company. There is still a company behind Uber which essentially judges drivers, and the company takes like 30%, depending on the country, 30 or 20% of the revenue of the
Mm-hmm.
drivers. Now you could think about an Uber where there would be no company at all. Instead, there would be this distributed network, which would actually include people and algorithms,
Mm-hmm.
and then you would join this network, you would drive your car, and then there would be these algorithms that would actually judge you
Mm-hmm.
and pay you. And necessarily, as we know, the algorithms would need to be neural networks and deep learning algorithms, because if you want to judge a complex behavior, it's not enough for you to write a program.
Mm-hmm.
So we can think about this future where there are people and there are some trusted algorithms that judge people, and so almost any business, almost any corporation, then you can then take and you can transform this corporation into this peer-to-peer network
Mm-hmm.
where there are people doing things. And so that's really something interesting. So let's go to the second slide.
Okay.
So this crypto networks have lots of benefits, and I think it's a small print. You guys don't have to read. But what are the benefits of these crypto networks? First of all, you are judged by your work. You can work 1 hour, 2 hours. Then you have really an incentive to innovate. To give you an example, let's take a look as an example of Bitcoin or Ethereum, right? If you take Bitcoin, when you mine Bitcoin, you know that you are going to get a certain amount of money for a particular mathematical operation, computational operation. So you have essentially fixed revenue, and the only way for you to increase your profit is to minimize costs.
Mm-hmm.
So there has been this huge innovation in ASICs and crypto chips that allow you to mine Bitcoin with faster efficiency.
Mm-hmm.
So then pretty much you can take any other network like Airbnb or Uber. What you can expect is that since it's a very much democratized network, people will be able to innovate, decrease costs, or improve service, and the network will be able to evolve fast. So these networks, you can hope that they can actually overtake corporations, because corporations have lots of management structures and they tend to die, and their efficiency tends to go down with time.
Okay.
Let's go to the next slide.
Okay.
So let me take like a very speculative slide for you guys. So let's take a look at milk. You go to a grocery store and you buy milk, right? And typically you have a brand of the milk that you like, and the reason why you typically buy this brand because you trust this brand, you want like good milk. So you have things like that. On the other hand, if you sell oil, there's no brands. It's just a commoditized product where if you have the specification of the product, you can sell this product. So there's this huge difference between selling milk and selling oil. Oil is a commodity and milk is a brand. So our entire world is split into commodities and brands. And if you have a brand, you actually invest lots of money into not really innovating the product, but keeping the brand. So there is lots of money going in this direction. So if we take this kind of our economy, the global economy, and shift some things in our economy from brands to to commodities, we can have really, really improved, things, prices going down, and people benefiting more.
Right. So what you're saying, let me see if I get this right. So what you're saying is, right, brands are ultimately amorphous, right? The stuff is still made by someone somewhere, right? So if you actually collapse, almost like what Dell did to computers 10, 20 years ago, right? Where it's the same commoditized parts, right? Maybe a different brand, a different name, but it's cheaper, faster. So this whole idea of people paying a premium for brands go away, right?
Absolutely.
You get things that will just be faster and cheaper, essentially.
Absolutely.
Okay.
Absolutely. And that's the idea. And but in order to have this faster and cheaper things, you need to have a standard. You need to have a standard for milk, and a standard for T-shirt, and a standard for socks. Like if I go to a store and buy a T-shirt. I don't really care what kind of T-shirt is that. I just want a quality T-shirt. So I may buy a Nike T-shirt because I trust Nike and I don't want to think. But if there would be a commoditized T-shirt judged by an AI algorithm, and I would trust this AI algorithm, I would buy that T-shirt, and then that would actually remove this brand premium, and the price would go down. So in the example of Filecoin, which I think Vaikit, you know very well, the Filecoin I think is one of the early examples of that, where you have storage. And you want to use storage. So, AWS is a great company, it's a brand, and you go and buy the storage from AWS. And if you are a small storage provider, it's very hard for you to compete with AWS because, you don't have such a brand.
Yep.
On the other hand, if you create a network where anyone would be able to put storage on, but there would be also constant quality evaluation of the storage. So the network would guarantee that the quality of the storage is no less.
So on that example, right? So AWS has a brand, and their brand, maybe is associated with high availability, right?
Exactly.
So you say, okay, great, I will go to AWS and use S3. But you get someone like Filecoin coming along and say, well, wait a minute, I've got a peer-to-peer. I don't have the brand yet, but I have the peer-to-peer storage infrastructure. But I'm 1/10 the price. At which point, customers would say, well, I may care less about the brand because I get to save 90% on my storage cost, right? So there's a break-even point at some point, right? So if Filecoin saves me 10%. I actually may not care because I'm like, I still really care about the brand.
Right.
But if you save me 90%, I might actually care less about the brand at that point and try you out. Right. That's kind of what you're saying.
Absolutely. But for you to be able to switch, you also need to be sure about the quality of this thing.
Right.
So the peer-to-peer network needs to constantly evaluate and test the quality of this Filecoin thing. So I can tell you, it's 10 times cheaper, and I have this AI algorithm that constantly evaluates the quality of that, and the quality is not the availability, the latency is not worse than AWS, but better, right? So
okay, I got you. So the first part of what you just described, right? So that already exists today with Ethereum, with all the people building distributed apps on top of it, and there's going to be more innovation coming. Where does your company Galactic Exchange sit, and what do you guys bring to the table that Ethereum doesn't have quite yet?
So let's go to the next slide, actually.
Okay.
Okay. So in order for all of those things to function, you have to be able to evaluate quality and enforce agreements. Essentially, you pay people for service. The problem with Ethereum and Bitcoin is that the transaction rate is low. They have about 10 transactions per second transaction rate. So they can't really run AI algorithms on this stuff. And when we talk about these smart contracts or agreements, the way AI should work, you basically run the same algorithm, the same neural network multiple times on different machines, And then you take the majority verdict, the majority decision, and that's the decision of your neural network.
Mm-hmm.
The reason why you need to do this is that in a peer-to-peer network, some of your peers can be bad.
Mm-hmm.
So there is the entire set of algorithms that actually were invented at MIT partially that allow you to vote, the good guys to vote and outvote the bad guys. So we're building this infrastructure where you have a peer-to-peer network. It accepts all kinds of messages and interactions between parties, but then there are these bots, there are these AI algorithms that are able to constantly judge and run algorithms on this data. So, for instance, let me give the example of the milk, right? Let's say I'm a store and I'm buying this milk, so I have an image of the milk, right, and whatever, or chemical analysis. And then so there's a deep learning network that takes this image and there's this chemical stuff and tells me whether milk is good or not. But this deep learning network needs to run multiple nodes so that there is a majority decision and not any particular node is able to, a bad guy is not able to influence the decision. So essentially, you have a peer-to-peer network. Out of this like thousands of nodes, right, you select like 100 nodes and you run the same neural network on these nodes. And the neural network actually analyzes your milk. And 70 nodes say the milk is good, and 30 nodes say milk is bad. So the 70, you think these are good nodes, and the 70 are malicious, because it should actually have been the same result. So this is this trusted computing that we are trying to build. So essentially,
you're building basically you're building a consensus layer on top and the consensus algorithm on top. Is that right?
We are building an architecture which is like blockchain, but is not a blockchain at all in the following sense. On the blockchain, if you have a smart contract, the smart contract gets ultimately executed on all peers of the blockchain. So it's very expensive because of that. You need like on Bitcoin or in our case, we say, okay, we can't really do this, it's too expensive. So we're saying it's a different architecture where there is a smart contract that needs to run on a particular piece of data. What we do, out of all of the nodes in this peer-to-peer network, we randomly select in a cryptographically secure fashion a pseudo-random subset of the nodes and run this smart contract. So the difference in our architecture is that in the case of Bitcoin of Ethereum, the smart contract runs on all nodes, and we have a trade-off.
So now, depending on the application that you run,
absolutely,
you may actually have more tolerance.
Absolutely.
I see. You have actually more tolerance on how much, right? How validated a transaction could be.
Absolutely.
I see. So it's not a one size fits all. Now on that point, so let me ask you this: does that mean that? So you guys are not building this on Ethereum?
No.
Right? This is your own protocol.
We have a network which runs alongside Ethereum and plugs into Ethereum and also actually Bitcoin. So we run a separate network, peer-to-peer network, which can talk to Ethereum. So it can be used from Ethereum and compatible with it.
I see.
But
how does that, so when someone says I'm building a distributed app on Ethereum, and so you come to me and say, hey, I can actually allow you in some ways to do the trade-off and the dialing. So I'd say, oh, great, I can't do that with Ethereum, but I still want to build it on Ethereum. So I do that with Ethereum, and with your protocol, I'm able to now essentially dial back the validation by default on Ethereum using your layer.
Absolutely. And the way it works, you just program Ethereum as you would program Ethereum. But at some point you say, I want to use this as a network. So the network pulls data from Ethereum, does the stuff, and then pushes data back to the Ethereum contract.
I see. You guys are almost like to use a bad analogy from the 80s. You guys are the GPU offload.
Exactly. This is exactly true. Exactly.
Right. So you got it. Got it. I see.
This is exactly the idea, and so we are. I think we pretty much discussed. That's the big thing. And we are looking for people that would like to try it.
Yeah, what's the status of the technology right now?
The current status is that we are going to run the prototype network on February 28th, 2018.
Okay, so a few months from now. Okay.
So you'll be people that are interested will be able to try this.
Okay.
And then we plan.
Send me the link. I'll include it in the post after
Okay.
this so people will have it. Yeah.
And then on May 31st, we're actually planning to run the production network.
May 31st of next year.
2014.
Right. Got
18.
it.
Right.
Got it. And so between now and then, so for people who are interested in signing up and testing this, can they go sign up on the site, on your site? Not yet.
Not
in February.
yet, but yeah, February.
February.
But you
Okay,
guys
got
can actually, maybe you can share my email.
I will share your email in this after.
Right.
Yeah. Got it. Okay. Very cool. You and your team are maybe give the audience a sense of how many people, where you guys are right now geographically.
Mm-hmm.
You guys have raised some funding.
Mm-hmm.
Maybe talk a little bit about your plans for the next 12 to 18, 24 months.
Mm-hmm.
Now, before we started the broadcast, I think Stan also mentioned a little bit about your fundraising plans vis-a-vis, would you do an ICO? Would you not do an ICO? So yeah, give the audience some thoughts.
This is actually a very good question, Kit. And so this is maybe also interesting for you guys to know. So there are these ICOs, but the law is that if your production network is not running yet, so then the token is an equity, and you may have lots of troubles potentially with the Securities and Exchange Commission. It's hard to do legally if the token is not a production level token yet. So we decided to postpone the ICO till the time when our network is actually a production network and people are able to use it, because at that time it becomes a utility token or a commodity. It's not an equity anymore legally. So anyone can buy this, like in a game, you can buy stuff, or you can buy Ethereum, or you can buy Bitcoin. So that's the decision we made, and this is something which our investors and us we made because we want to separate ourselves with the current huge number of ICOs and people without any technology, just publishing white papers. We just want to get through all of this stuff, and because we really are interested in the long-term development of this company. So we raised $1.5 million from two investors. We actually are in the process of raising another small round, although it's actually the money we have now is enough for us to get to the production level, but we may actually raise a small round, and then on May 31st, hopefully we'll run the production network, and at that point we may actually start selling our tokens, which at that point which will be much more mature, because it's going to be a mature technology, secure, we'll know that it's not been hacked. So at this point it will be much more fair for common investors, for people around the world who have no idea about this crypto stuff, to start actually buying this stuff. Yeah. So if you guys, anyone on this call also is thinking about ICOs, so this kind of more conservative strategy may be good, because then you don't have to deal with all of the legal stuff and security regulations and stuff like that.
Yeah, I think the days of doing an ICO based on a pure white paper are gone.
Right.
No, that's great. That's great. And so talk a little bit about applications, right, where this could be interesting. What are some of the specific applications where people might go, hey, I want to use Ethereum and you guys versus just pure Ethereum, where that may not be as possible before?
So the first application that we are thinking about is a distributed exchange, where it's a high-frequency exchange. Think about like high-frequency trading on Wall Street. So essentially, we're thinking about putting like the entire NYSE or NASDAQ and creating a distributed version of NASDAQ.
So not a crypto exchange per se, but any kind of exchange, including stock exchange and
right.
Okay.
Right, and definitely crypto exchange is kind of the straightforward thing, exchanging crypto tokens, because currently there is no high-frequency crypto exchange. There are some exchanges which are pretty slow.
Yeah.
So we are thinking about this, and since the network is able to run AI, people will be also able to, on this exchange, to put AI algorithms and deep learning, and so you have the entire high-frequency hedge fund thing. So we're thinking about talking to hedge funds, crypto hedge funds, and putting this, crypto trading on this platform, including the AI stuff.
So yeah, so let me take a step back. I'm not sure I quite understand the AI angle in this case. So walk me through the AI angle. What do you mean by that?
So the AI angle is that, let's take a look at how the NYSE works or Nasdaq works in the early days, right? The old days. There would be this trading floor, and then there would be these traders, and traders would wave their hands and say bid and ask and order and commit, all of those stuff. So this thing, if you think about these traders from the computer science perspective, it's a publish-subscribe system. It's a multitask system because when you raise your hand, it's multicast. You're multicasting your bid, ask, and order. So since we are building this actually, publish-subscribe multicasting system, it's pretty much the direct analogy of New York Stock Exchange. So then you have these messages which are actually published on this crypto system. But then you actually may want to run some AI algorithms on this, and those could be public AI algorithms and private AI algorithms. Public AI algorithms would be algorithms that currently Nasdaq has, where they have certain rules, they prohibit certain speculation inside the trading. So there are algorithms which are known to everyone, which actually protect the exchange. There are some money makers on the exchange. Those are also be public algorithms. But there are also private algorithms, so you could actually run private AI by connecting to this exchange as to a message bus, and then you would privately run your AI algorithm, and then you would do bid, ask, and
but the algorithm would be running in your network.
You would run it in your network.
In your network.
If that's something which is your intellectual property, you would just connect to this peer-to-peer network, but you would run this algorithm on your side.
Right, and because your transaction speed is much faster than the Ethereum chain, you're able for them to connect. I see. Okay.
And Ethereum was like 10 transactions per second. We can scale to billions of transactions per second.
Got it.
So,
okay. Next slide, or which slide?
I think we pretty much talked about everything.
Okay.
I think we can just take questions.
Okay.
From the audience.
Let me see. I do have a few questions that people sent prior. Just give me 1 second while I pull it up this way. All right, we've got a few of those questions answered already, mostly around applications. So one question that came is, obviously Ethereum is still evolving, right? There are, different forks that's happened. There's recent upgrades that are happening. How do you make sure that what you guys are doing are not replicating what the Ethereum core is doing? And how confident are you that what you'll be doing would be complementary in the long term?
That's actually a very interesting question. So, one interesting thing about Ethereum is that if you take a look at Ethereum, if you can just go to if you go to the source code of Ethereum and you see how many committers are into the Ethereum code base, they have about 17 engineers. So Ethereum is kind of an open source project. They are not moving so fast, and also for them to add things, they have to go through a pretty long process. So we hope that we can do things faster. I think it's like a first-comer advantage. And we hope that if we create our network faster, then the Ethereum guys come to the same architecture. We can do this. But the architecture, if you think about this, that's pretty much the only architecture which is possible, right? If you want to do things faster than other people, then then it has to. You have to move from the technology where you run everything on all computers. You have to move to the technology where you run things on a subset of computers. So it's a very simple idea that we are trying to pursue. I think that's the only way we think computationally possible to have such a computational speed. So we hope that we'll be able to achieve this, and then definitely we like Ethereum guys. And also, this is also going to work with Bitcoin. So it's also going to be
you're agnostic in terms of which chain you actually plug into.
And currently, actually, Bitcoin, they are doing this RST. I think it's called smart contracts, which are very good actually saying, and they're going to be very strong competitive to Ethereum. So I think what's going to happen in the future is that it's going to be like iPhone and Android or Pepsi or Coke. You're going to have Ethereum and Bitcoin and those two kind of camps. They're going to have pretty much the same features. And I think there will be two platforms, two competing platforms.
Now, next question I have, just going through the list. One question is that, is your code base going to be open source?
Absolutely. So we're actually open sourcing our code base under the same code base as Ethereum, because we kind of borrow some of the code from them, and they are a GPL. So necessarily we also pretty much need to be GPL as Ethereum, because we are taking some stuff from them. So it's going to be the same license as Ethereum license, pretty much for the entire thing.
Got it. Very cool. Let me look at the next one. Here's another question. Stan, your team is split. Your team is mostly Europe-based right now.
In Ukraine, right?
In Ukraine right now. So we see this all the time, right? Solidity developers, or just in general, blockchain-related developers, hard to find, getting harder to find. What are you seeing in Ukraine?
Right. So I think in Ukraine there was this kind of old-time mathematics history with all the Soviet Union and stuff. So I think that's in crypto and mathematics we were developed. So I think that's why in Ukraine so many people are doing crypto.
Is that right? So so in Ukraine it's a hotbed for crypto talent right now?
It's a very, very big, and we also have some crypto exchanges in Ukraine. So lots of crypto stuff is happening in Ukraine.
Got it. Interesting. I think most of the other questions actually have already been answered by you, and so this is actually great. We actually managed to run through all our questions. I want to thank you for taking time. This is really exciting. I will include the relevant links in the post when I repost the video back into the group. Please keep us in the loop as things develop. Q1 is going to be a big quarter for you guys next year. So let's keep on talking.
Thank you, Aki. Thank you for the invitation.
Yeah. So with that.